Page 316, problem number 15. Sketch the graph of the function y equals 1/2 times the cotangent of x over 2. Okay, now if I were to graph just this function here, if I were to graph y equals the cotangent of x, my cotangent graph looks something like this. It has an asymptote right at the y-axis, comes down, looks something like this. Has another asymptote here at pi, and then we'll do the same pattern over and over. Now let's think about what these two values here do to this graph. First of all, the 1/2 will make it half as tall, so it's just going to be squished down a little bit. The x over 2, though, is going to change the horizontal stretch. How is that going to change? Well, let's just think about where my original asymptotes are. One asymptote is at x equals 0. One is at x equals pi. So what I can do is set x over 2 equal to 0 and set x over 2 equal to pi. And if I solve both these for x, I'll know where my asymptotes of my new function are at. Well, multiplying both sides by 2 here, I get x equals 0. So I will still have an asymptote at 0. Multiplying both sides here by 2, I get x equals 2 pi. So my asymptotes are going to now be at 0 where it was before, and at 2 pi. So let's just label those 0 and we'll label 2 pi. We can even go out here to 4 pi and put another asymptote because we know that these trig functions are periodic and they will continue on and on forever. Okay, so my graph is going to be half as tall, so I'm going to kind of make it a little more squished, and we'll have these asymptotes I already marked. So my graph's going to look something like this. So it's going to come through here, continue on forever. I'll get another curve. And now that we've sketched it by hand, let's pull out our graphing calculator and just take a look at the graph on there. So I'll start with 1/2 times the cotangent. Now I can't, there's no cotangent key, so I'm going to type in 1 divided by tangent, 1 over tangent of x over 2. And we'll close both those sets of parentheses, and let's graph this. So there's that curve. I can see there's an asymptote here at 0. There's an asymptote over here at 2 pi. And I've got the same kind of curve that we sketched by hand.